Dear students, in this lecture we will discuss on hydrostatic forces acting on plane surfaces. Consider a plane surface upon which uniform pressure is acting. That means at each point on the plane surface, the pressure exerted will be same or uniform. And this pressure can be represented by a resultant force which is equal to pressure into area upon which this pressure is acting. And this resultant force F, it passes through a single point, and this particular point is known as center of pressure. And please keep in mind that the pressure will always act on a surface, whereas force will act on a particular point. Now let us consider hydrostatic pressure distribution. Here we have a plane surface which is in contact with the static fluid mass. In this case, the pressure exerted by the static fluid mass on this surface, it will not be uniform. We know that according to hydrostatic principle, when we move down, the pressure will keep on increasing. So here, the pressure at each point on the plane surface is not same or uniform. It is varying. It is linearly varying. Please note that this pressure will always act normal to the surface which is in contact with the fluid mass. And this pressure can be represented by a resultant force F which will act at a particular point, and this point is known as center of pressure. So in this case, center of pressure will be located below centroid of the area. Whereas in case of uniform pressure distribution, the center of pressure and center of area will coincide. So here we can conclude that when we talk about hydrostatic forces acting on surfaces, it mainly deals with fluids under rest. That means there is no relative motion between adjacent fluid layers. So as a result, the velocity gradient between the two layers will be zero. Since shear stress is directly proportional to velocity gradient, we can say that shear stress will be zero. So when we consider hydrostatic forces on surfaces, it will mainly focus on the pressure force which will act normal to the surface and the gravity force due to self-weight of the fluid particle. Now we will define hydrostatic pressure force and center of pressure. Hydrostatic pressure force is also known as total pressure. This is hydrostatic pressure force. It is a force exerted by a static fluid on a surface, and the surface can be either plane or a curved one when the fluid comes in contact with the surfaces. And please note that this force will always act normal to the surface. Whereas center of pressure is defined as the point of application of this total pressure force on the surface. And please note that the unit of total pressure or hydrostatic pressure force will be Newton. Now we will consider 4 different types of plane surfaces submerged in a static fluid mass. Now let us consider a horizontal plane surface which is submerged in a static fluid mass. And this plane surface is located at a distance h from the free surface. Since it is a horizontal surface, we can say that every point of the surface is located at the same depth from the free surface of the liquid. That means the intensity of pressure will be uniform along the surface. And this pressure intensity is given by P is equal to rho g h. Now let C denotes center of gravity of area of the plane surface, and h bar denotes distance of the CG from the free surface. And let h star be the distance of center of pressure from the free surface. As every point of the surface is at the same depth from the free surface, we can say that h is equal to h bar is equal to h star. Now the total pressure or the pressure force F is equal to the intensity of pressure into area upon which this pressure is acting. So here we can write it as rho g h bar. Since h is equal to h bar, we can write rho g h bar into A. And finally, we can express the total pressure as rho g A h bar.